Hi, I'm Matt with Ardent Automation, and today we're going to scan this simple battery charger with our LMI Gocator, and we're going to look specifically at this back panel here and simulate an end-of-line inspection using common Gocator tools. So let's put it on the scanner and see what we get. As we watch the battery charger pass underneath the Gocator, note a couple of things. First, it's not required that the battery charger be fixtured in any way. And second, the angle that it's sitting at right now can be corrected for in the software. Just going to look at this backplate here and simulate a few inspections that you might look for at the end of the line. Such as you might want to make sure your screw wells actually were formed and are to the right height. You're going to want to check and make sure your screws are all driven into the right depth. And you want to make sure that there actually is a QC sticker on this part. So we're going to walk through some quick, simple tools and show you how it all looks inside the LMI software. All right, here we are inside of the Gocator software. The first thing I'm going to kind of show you is just some of the basic view options. So right now we've got the 3D point cloud turned on, but we've also got our intensity map behind it. So I can turn off the intensity, and now I just have a purely 3D point cloud model, and I can actually spin it here and you can see all the different dimensions. And if I zoom way in, you're going to be able to see individual dots that are each scan point. And then we're going to flip over and look at the intensity. Turn the intensity off. There we go. Right, there we go. And so what you have here is going to be extremely similar to what a standard 2D camera would give you in a grayscale. And this is a newer feature to the LMI Gocator, and it's one of our favorites because what it allows you to do is actually analyze your image as if you were using a standard 2D camera, but also you can use features out of the 3D as well, so you're really getting the best of both worlds in this case. Next, I'm going to start walking through the different tools we use to do the analysis. So as I described earlier, the things we're going to look for is the height of the screws to make sure that they're in all the way. We're also going to look for this QC sticker, and I can talk about how to find the heights of the individual wells as well. Now we're going to start taking a look at the different tool sets and how they all go together. So the first thing that we're going to do is the surface transform. As I noted in the actual scan, this surface is tilted, so that's why you see this color gradient going down the surface. But in reality, we want to look at it and analyze as if it's a flat surface. So that's what the surface transform tool does. And then it generates this output. Now you can actually see a flat surface and make all your comparisons relative to that flat surface. The next thing we're going to look at is the screw heights down here. Now, one of the cool things about the LMI software is there's several ways to accomplish that task. So we're going to show two simple versions, and just know that if you want to get even more detailed, there's other ways to do this in a more detailed fashion. But what we're going to do first is we're going to look at these left and right screw height tools that I've got here. And what they're actually doing is they're using a profile of a section. And it's simply over here in the model tab, you simply lay out where you want your section to be. And so that's the section that you're seeing over here. And then you are drawing in a box that's showing or looking for the max Z height inside of this area. So as we click through here, you can see how it changes. So that's one way to do it, and that's a pretty simplistic way. Another one is we are using the surface dimension. So this time we're actually looking at it as if it's got a box, right, a three-dimensional cube actually, and we're looking for the max Z height inside of that cube. Now we've also got it anchored to this point on top of each screw, so no matter how the part moves, it's going to be anchored based on other dimensions that we use to set up. Now we want to find and verify that we've got 4 raised areas around where the screws are inserted. Now this one, we're going to go pretty simplistic, and we're just going to run a blob tool looking for that height measurement that fits inside of a defined area. But you could take this several steps further, actually define like a donut type area. Looking at just that rim, you could get surface flatness, you could get the average height, you could get the max min. You can do a lot of things with that and get very detailed if that was a critical component. But for now, we're just trying to check and make sure that they're there, that we have all 4 of them, and we can also output the center points and make sure that they're in the right location. Last, we're going to look for this QC sticker down here. Now, being a sticker and it's flat, the 3D data is really not going to help us in this case. So we're going to go ahead and just turn off the 3D data and look purely at the intensity data, which again is very similar to what a 2D black and white camera would generate. And so we're going to use a simple blob tool, but the interesting thing is now we're strictly using intensity just like you would do in a 2D scenario. So particularly here, we're defining our region where the sticker is supposed to be. We're giving it an intensity threshold so you can see, looking for this whiter area. And then we are giving it a max and min area. And then one of the critical components here, because you have other areas that are, varying in intensities, we're using the aspect filter to define this oval and make sure that it meets that criteria. So as we flip through a few of these, you'll be able to see that it sticks with it regardless. Thank you for watching this quick demo on some of the common tools used for end-of-line inspection on the LMI Gocator. If you'd like to see a trial with one of your parts, please feel free to reach out to us. And as always, we're happy to answer any questions along the way. Thank you.